Okay, hello everybody, what's going on? This is Muhammad, welcome to another video. In this video, I'm gonna be proving this important property. So it says that for a strictly increasing and continuous function f on a closed interval a and b, we need to prove that the integral from a to b of f of x dx, which is the area under f of x from a to b, plus the area under the inverse function f inverse of x dx from f of a to f of b, the sum of the two areas is equal to b f of b minus a f of a, which is an important property that might help us solve different types of problems. Okay, so if you're interested, pause this video, give this problem a try, and then keep watching this video for a solution. Okay, so in order to prove this, I will be starting from the second integral here, okay? Okay, so I'll start by the second integral here, and then I will use integration by parts to prove that it's equal to the right-hand side minus the first integral. And in that, I will be proving the property. Okay, so let's start with that. Okay, so first of all, okay, I'll start with the integral. I'm sorry, let me use the black color. Okay, so let me put here the word proof, okay? So the proof is the integral from f of a to f of b of f inverse of x dx is, okay, so I'll start with that, okay? Okay, so I'll start with the second integral. So to solve for this integral, or we can call it, okay, so what we can do, we can call this I2, okay? So I2 is equal to this integral. Now to solve for this integral, I will let u equals f inverse of x, and I will differentiate. I'll use integration by parts. So this is gonna be what the derivative of this. Okay, so I'll keep it in terms of the derivative, okay? dx. And then dv is equal to dx, and from that we get that v is equal to x. And then we have to multiply this by this, and then subtract the integral of this times this. And I'll put in red a negative integral here so that we know how to do this. Okay, I'll put this in a box, and then I will highlight it so that everything is organized and easy to follow. Okay, good. Now, so now I2 becomes what? I2 becomes what? Becomes x f inverse of x. And we need to evaluate that from f of a, right, to f of b. And then minus the integral, the integral from f of a to f of b of x times the derivative d by dx of f inverse of x dx. Okay, so let's start with the first term here. The first term is nothing but x f inverse of x from f of a to f of b, and that is going to be equal to, we first need to substitute the upper limit instead of x, so that's going to give us f of b, f inverse of f of b, which is b, so that's going to give us b f of b, minus, if we substitute the lower limit, is going to be f of a multiplied by f inverse of f of a, so f inverse of f of a, which is simply a, so it's going to be a multiplied by f of a. Okay, so in a way we have proven half of the problem here, half of the property. Okay, now let's worry about the second term. Okay, the second term is, okay, which is simply the integral from f of a to f of b x multiplied by d by dx of f inverse of x dx. Let me call this which is the second term. Okay, so let me call this I3. Yeah, let me call it I3 for the sake of simplicity. So I3. So in order to evaluate I3, I will simplify it because it's hard to deal with the inverse. Okay, so I will let the inverse of the f inverse of x, okay, equal to w. So let w equals f inverse of x, okay? And then let's take f of both sides. So that's gonna leave us with f of w equals to x. And then I can differentiate both sides. Okay, so it's going to be f prime of w and then dw by dx equals to 1. And that would leave us with the fact that dw by dx is nothing but 1 over f prime of w. And also at the same time, dx is equal to f prime of w dw. Okay, so let's take now let's see how the limits would change, okay, with this type of substitution, this particular substitution. Now x, the lower limit is f of a, so let's see how would that change. That makes w equals to f inverse of f of a, which is simply a. And then when x is equal to f of b, then w would become what? Would become f inverse of f of b, which is nothing but b, okay? So I3, with that, I3 becomes what? The integral from a to b, and then instead of x, we're gonna substitute f of w, right? So I will replace x by f of w, multiplied by d by dx of f inverse. Now you can pay attention here, guys. You can notice that f inverse is w. So df inverse of x by dx is dw by dx, which we have proven here that it is equal to 1 over f prime of w. So I'll just put here, instead of the derivative of the inverse function, 1 over f prime of w. And then we're left with dx here. dx is nothing but f prime of w dw. Okay, so I'll put that here, f prime of w dw. And you can notice that this would cancel out with this, okay? And basically we are left with the fact that this I3 is equal to a of from a to b, f of w dw, which can be replaced by, since w and x and y are dummy variables, so I'll just replace that with x and f of x. So this is going to be x, okay, dx, okay, since w and x are dummy variables. Okay, so now let's take I3 and plug it back into I2. Okay, so I2, which is simply I2, which is the second, I2 is simply the integral from f of a to f of b of the inverse function of x dx. Okay, so let me write that down here. Okay, so the I2, which is the integral of f of a from f to f of b of the inverse function of x dx is equal to b f of b minus a f of a. This is taken from here, right? Okay. And then we need to subtract I3. So subtracting I3 means that I need to subtract here the integral from a to b f of x dx. Now, if we move the last term to the left-hand side, we're done. Okay, so it's that tells us that the integral from a to b of f of x dx plus the integral of f of a to f of b f inverse of x dx is nothing but b f of b minus a f of a, which is simply going to be a rectangle, a difference of two rectangles, a big rectangle and a small rectangle. And this can be geometrically interpreted by that, because the area under f of x from a to b is exactly equal to the area under f inverse of x, but on the y-axis. So it is going to be the area of a big rectangle minus the area under f of x dx. So this can be simply geometrically interpreted, but I would leave it. I would conclude the video with this proof here. So I have successfully proven that the integral, which is the area under f of x from a to b, plus the area under the inverse function from f of a to f of b is nothing but b f of b minus a f of a. And that's it. If you guys like this video, don't forget to hit like, share this video. If this is your first time here and you want to know more about brain teasers, riddles, logic puzzles, viral math problems, and all types of mathematics related problems, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you for watching and see you in another video.